All right, so solving inequalities. Before I get into how to solve these inequalities, I want to make note of something that characteristics of the integers on the number line. So before we learned about negatives, we were familiar with positive numbers. The larger the digit, the larger the value. However, when we were introduced to negative numbers, I like to call this negative world. In negative world, the larger the digit appears, it actually means the smaller the value. So something such as negative 100 is less than negative 1. That is true, but something about seeing this 100 digit makes me believe 100 is a big number. But 100 in negative world is actually a smaller number compared to negative 1. So that was something that was a little different for me when I was younger and learned about negative numbers. And I want to also point out some facts that we're going to need to use before we solve inequalities. So let's start with something that we know is true for sure. 2 is less than 8. Okay, so 2 is less than 8 in positive world, everything's fine. The larger digit is large, the smaller one obviously small. However, if I take the same inequality into negative world and make this a negative 2 and a negative 8, the value of negative 2 is not smaller than negative 8. This is no longer a true inequality. So when you take two digits into negative world, remember it's going to be reversed. The concept is backwards. So what appears to be a small number is actually a larger number, and what appears to be the larger digit is actually the smaller number. So in order for this to be true, we have to flip this inequality. So one thing we need to remember, when you go into negative world, your inequalities will no longer be true. So we're going to have to flip them. Now let's talk about what's going to get us into negative world, because we need to be cautious about that so we don't end up with false inequalities that are not true. So let's start with something like what we had before. We know 2 is less than 8. And I said that going into negative world, it makes it into a negative 2 and a negative 8. Now, what can I do to the 2 to make it into a negative 2? How does this happen? What's going to take an inequality into negative world? How is this going to happen? Well, there's two ways. So I'm going to do two of them. And I'm not putting the inequality yet because I want to show you, well, maybe I can just put it and show you what happens. So starting with the positive inequality, what makes it go into negative world? What mathematical step is done? So that's what we have to be cautious about. What can I do to the 2 to make it into a negative 2? One thing you can do is you can divide it by negative 1. And 2 divided by negative 1 gets me negative 2. And 8 divided by negative 1 gets me negative 8. So by dividing by negative 1, I go into negative world where everything is backwards or inverted. And so now we have to flip that inequality to a greater than sign. That's one way. What's another way we can take an inequality into negative world? What mathematically can be done that'll end up in this situation? You can multiply by negative 1 on both sides. If I multiply both sides by negative 1, that takes me into negative world. 2 times negative 1 is negative 2, and 8 times negative 1 is negative 8. So again, doing this and doing this gets me into negative world where everything is reversed. So when we're doing our math problems, we don't want to leave our inequalities with the wrong answer. So we're going to have to look out for this. Okay? We have to look out for any time we divide or multiply by a negative number, because when that happens, we're going to end up with false inequalities. We do not want that. So we're going to have to remind ourselves that we're going to have to flip the inequalities so we can continue to have true statements. So let's go ahead and write that down. Something that we need to remember in doing our problems. So we'll just put a little note. And again, it doesn't have to just be -1. It could be division of any negative number and multiplication of any negative number. This will bring us into negative world. So anytime you multiply or divide by a negative number, you must flip the sign. You can say reverse the sign or flip the inequality sign. Now, and again, this is when you apply the inverse operation to both sides. So anytime you multiply or divide by a negative number, you must reverse or flip the inequality sign. And again, this is the step when you're doing it to both sides of the inequality. So let's see what this looks like with a math problem. Example 1. I got my paper dirty. So let's say x divided by -3 plus 4 is less than 13. So, and the instructions are going to be to solve and graph. Okay, now, same as before, I like to put the line through the inequality or equal sign. So this replaces our equal sign, so this is the same place I would put my divider in. And this is similar to what we've been doing. You want the x to be all alone on one side. And I noticed there's two numbers that need to be eliminated, so that reminds me that I'm going to have 2 steps to do. And this is going to be helpful because we're going to be able to predict whether or not it's going to take us into negative world and if we're going to have to reverse that inequality sign. So let's see. Of these 2 numbers, the ones you want to eliminate first is the addition or subtraction first always. I see an addition here, so my first step is going to be to get rid of it by subtracting. Then when I see this division of -3, I'm going to do the inverse operation and multiply by -3. Now looking at these steps, I have to ask myself, did I multiply or divide anywhere in my problem by a -3? And clearly right here, I did. I mean, by a negative number. So I'm looking to find out, do I multiply by a negative number? And because of this, I know I'm going to have to flip the sign. Okay, I can already tell that I did multiply by a negative number. I will go into negative world. My inequality will be false unless I flip it. So now let's go ahead and solve this. That's 0. I'm going to bring down what's left. X over -3 is less than 9. So step 1 is done. Step 2, I now know I'm going to multiply both sides by -3. And I can put a 1 under there. These 3's become an invisible 1x. And over here I get -27. Now, the last thing I need to remember is because I multiplied both sides by a negative, this inequality is not going to be true. To get a valid answer, I'm going to have to flip it. And now I know that is my true final answer. All right, next one. Example 2. 5x minus 4 is greater than or equal to 11. Oh, I forgot to graph this one. Just a minute. Let's graph this answer really quick. So, to graph this, we want to know where are all the x's that make this true. So I like to think of this as filling in the blank. So think of a number that's greater than negative 27. Here's negative 27. Positive 27 is bigger than negative 27, and positive 27 is on this side. So I know that I'm going to shade everything to the right. But what happens at negative 27? I see this is an open circle. I don't want to include negative 27 because negative 27 is not greater than negative 27. So that's how we exclude it. And again, I chose positive 27, so that tells me that all the other numbers are on that same side, the right side. And that's how you display your answers visually. All right, so example 2, back to that one. Again, your goal is to get x on the left side. And we have 2 numbers to eliminate. So it's going to be 2 steps. Of these 2 numbers, again, you always want to start with addition or subtraction. So this is the first number to eliminate since I know this represents multiplication. That's my second step. So subtraction of 4, opposite operation or inverse operation is to add 4. And then to get rid of this 5, I see it as a multiplication of 5, so you're going to have to divide by 5. Now let's just look over our steps. Did I multiply or divide by a negative number in this problem? No, we did not. We divided, but it was a positive 5. It was not a negative 5. So in this case, you do not have to flip it. It's very helpful to write this down ahead of time because you kind of already have your plan for the whole problem. So let's go ahead and solve it now. 5x is still there. Please bring them down. I don't like to come back up here and do the math. Bring it down so it's leveled in with the problem on the other side on the same line. That's 15. Step 1 is done. Step 2, getting rid of that 5 by dividing by 5. That's your invisible 1, x, and it's greater than or equal to 3. And again, looking through our scratch work, we did not multiply or divide by a negative on both sides. So our inequality we know is going to be okay. It did not make it into negative world, and we're good. So let's go ahead and graph this solution. You want to think of a number that's greater than or equal to 3. So 3 is over here. I'm thinking 4. 4 is greater than or equal to 3. So I want to include the 3 because it could be equal to 3. And the number 4 that I chose is on the right side along with all the other numbers I could have chosen. So that's the solution, visual solution to this when you graph the inequality. And the third example, let's flip this over. W divided by 2 minus 7 is greater than negative 1. Again, I want to keep W, 2 numbers to eliminate. So in this case, we don't have to distribute, we don't have to combine like terms. We're ready to start our inverse operations. Addition and subtraction is always first, so I'm going to eliminate this negative 7 by adding 7 to both sides. And I see this is division of 2, so I'm going to multiply by 2. Now looking over my steps, I can verify that I am not multiplying or dividing by a negative number. So in that case, I do not have to flip the sign. This is multiplication of a positive 2. And just to write it down so we have a plan on what we're going to do. So let's go ahead and start by adding 7. Bring down my W over 2. And this side you get 6. Now step 2, multiply that by 2. This kind of looks weird. If you want to put a 1, you can. and 2w over 2. That's your invisible 1 in disguise. And on this side you get 12. And again, we don't have to flip it because this operation did not take us into negative world. It's all good. So that's your answer. Let's see what happens. On the number line, we have to show all of the solutions that are greater than 12. So pick a number like 13. 13 is greater than 12. Where is 13? On the right or on the left? 13. Since 13 is on the right side, it lets me know that all the other numbers that will work are also on the right side. And what happens at 12? I don't want it to equal 12 because 12 is not bigger than 12. So you leave it open. Again, the door is missing. Leave it open. Okay, so now let's do example 4. And for this one, it's going to be negative 6x plus 7 is less than or equal to negative 29. And again, trying to get x isolated on the left side. So what we're going to do is we're going to do our 2 steps and eliminate those 2 numbers. Since you see it's a addition of 7, we're starting with addition first always. So we're going to do a subtraction. That's the inverse operation. And once the 7 is gone, we're going to have to eliminate that negative 6. The negative 6 is being multiplied, so that tells me I'm going to be dividing by negative 6. Now remember the rule. Anytime you multiply or divide by a negative number, we are going to end up in negative world where everything is backwards, so we have to flip that sign to make sure we have a valid answer. Now, division is always going to be on the second step, so is multiplication. So you're always going to check your second step to see if there's any negative operation there. All right, so let's go ahead and subtract 7. 29 and negative 7 gives you negative 36. And we're left with a negative 6x. And that's the end of step 1. 7 is gone. Now we're going to eliminate that negative 6 by dividing by negative 6. That is your invisible 1x. And this is going to be positive 6. And before we get to our final answer, remember, this is in negative world. And because we are there, we're going to have to flip that sign or we will have a wrong answer. Now, it won't be obvious because we don't know what x is. But we do know that what happens mathematically, and this must be done. Now, what does this solution look like? Starting at 6. I'm going to think of a number that's greater than 6, like 10 or 7 or 8 or 9. So the numbers that I'm listing are going to be on the right side of 6. That means that's where all the solutions are going to be. What happens at 6? Is 6 greater than or equal to 6? Yes, it is. So we want to include it by making it a closed circle. And again, it has the door, so I close it. And that's how you graph inequalities. Just remember, you're always going to want to check that second step to see if you ended up multiplying or dividing by a negative number. That's the only thing you have to watch out for to determine whether or not you're going to flip that sign. Everything else is the same process as you would in a regular equation. All right, there you go.